For another, maybe a little more exotic problem involving gravitational potential energy, let's consider a roller coaster. We'll shift over to the problem itself. Find the final speed of the object. Here with the roller coaster, we have the object initially located near a peak, 52 meters above the ground, maybe just slightly to the right of the peak. So if the initial speed is 0, still it's going to begin rolling and go down. And later at a second peak, 40 meters above the ground, well, we want to know how fast it's moving at that point. It's another problem, excellent for conservation of mechanical energy. Well, let's shift over and see how we might solve this problem. Small version of the picture so that we can bear in mind exactly what's going on. The energy is approximately mechanical. So try the conservation of mechanical energy. Need an uppercase M there to make it look a little bit better. Should point out that in this problem, certainly friction exists, but it can be ignored at least to a first approximation. The friction is going to be very small compared to the kinetic energy of the car in motion and the gravitational potential energy of the car. Kind of got ahead of myself here. Mechanical energy initial is going to equal mechanical energy final. As the object is in motion, there's kinetic energy. It also has a vertical aspect to it, so the gravitational potential energy is going to show up. The sum of the kinetic plus the potential at the initial time is going to equal the sum of the kinetic and the gravitational potential at the final time. The kinetic energy, of course, 1/2 mv squared. Gravitational potential energy, mgy, initial and final values. Once again, just like with the free fall motion, the mass appears in every term in the problem. You can divide both sides by the mass. It cancels out. So we can rewrite the equation, simplify it a little bit, just losing the mass. Plug in the values that we know, 1/2 times the initial speed is 0, plus the g, 9.8, the y initial is 52 meters, will equal 1/2 the final speed, just calling it v here to make the algebra a little bit simpler rather than carrying around a subscript, plus the g, 9.8, and times the final height, 40 meters, and this can be solved for v. We find that the v is about 15.34 meters per second.